Many integration formulas can be derived using the corresponding derivation formulas. While other integration problems require more work. Okay? Some of them can be solved using substitution or change of variable. But there are problems that cannot be solved using substitution or change of variable. And therefore, it will require other techniques of integration. So for this video, I'm going to share another technique of integration, which is called integration by parts. Integration by parts is a special method of integration that is often useful when two functions are multiplied together. Now, these two functions are not ordinary functions. Or they are not basic functions, or shall we say functions not similar in nature. Meaning to say, it could be that one function is algebraic, the other is trigonometric, or algebraic and the other is exponential, or exponential and the other is trigonometric. Now, this method is based on the product rule for differentiation. So, this is the formula for integration by parts. Integral of u and dv is equal to uv minus the integral of v du. Okay. So, let us prove this one. So, let us review on the product rule. Derivative of a product uv is u times derivative of v with respect to x plus v times derivative of u with respect to x. Now, if you will integrate both sides, integral of this one, this will result to this one. So, integral of u times v will multiply dx sa both sides. It would be u dv with derivative of v with respect to x times dx, and then the second one, v times derivative of u with respect to x times dx. So dx will be cancelled. Yeah. And to solve for integral of u dv, we are going to transpose this term to the left side, and the result will be this one. Integral of u dv is equal to uv minus integral of v du. So generally, integration by parts is a trial and error process. Bali, you select one function as your u, the other would be your dv, and then observe if it will result to a simpler integral. No? So in most cases, the most difficult part is this one, integral of v du. So when you select your first function and second function, make sure that it will result to a simpler integral v du. So we are going to solve sample problems that will explain this one, especially the trial and error process. So the first example is evaluate the integral of x cosine x dx. Now, this cannot be solved using change of variable or substitution, because if you let cosine x as your u, then your du will be negative sine x dx. So, pag cosine x ang function, which is trigonometric, ang derivative is also trigonometric in nature. Oh, now we cannot find sine x, di ba? Or, if you let x be u, the derivative is algebraic. Oh, and we cannot make use of cosine x. Therefore, we'll have to use integration by parts. So, again, as I have said, this is trial and error process. So, we have two options. Let us make x as our u, and the second one, cosine x as our u. So, option 1 is u equal to x, and of course, what is left will be your dv. Okay, integral of u dv. So, u, the rest would be dv, cosine x dx. And let's differentiate you. Du is simply dx, and dv, we integrate integral of cosine x. V is equal to sine x because the integral of cosine is sine. Our option 2 is let u equal to cosine x, and our dv would be the remaining function, x and dx. So let's differentiate u. Du is negative sine x dx. And let's integrate dv. Integral of x dx is x squared over 2. Now, as I have said, the critical part here is integral of v du. Right? The formula is integral of u dv is equal to uv minus integral of v du. So let's focus on the integral of v du. So let's try to look at option 2. Integral of v du, mas na-complicate siya because the power of x increases. Initially, it's x. Now, it's already x squared. So, this is not a good selection or choice. Ba? But if you insist on using cosine x as your u, then the power of x will continue to increase. So, mas difficult na siya. Whereas option 1 ka, integral of v du, integral of sine x dx, we have the formula there. We have the standard form. Therefore, we are going to use option 1. Okay. Option 1. So, integral of u dv is equal to uv u x times v minus integral of v sine x du. For the first term, there's no problem. The second term naman, integral of v du. Make sure na it would result to a more simple na integral. So, integral of sine x is negative cosine x. So, the result will be this one. And multiply. Final answer is this. X cosine x, x sine x plus cosine x plus c. Okay. The second example is this. Evaluate the integral of x squared times e to the x dx. Again, these are not basic functions, or these are not similar functions. X squared is algebraic, e to the x is exponential. Okay. Ang nature nila is different. Bali, if you consider substitution or change a variable, if this will be your u, e to the x, du will be e to the x also. Or, pag u ang x could be your u, du is 2x dx. How are you going to use e to the x? Diba? So therefore, this can be solved using only using integration by parts. And again, let's do the trial and error na procedure. Because for beginners, you don't have any idea, okay, what will be your U and what will be your DV. So first, you have to choose several options and then later select kung what option will result to a simpler na integral. So option 1, our u is x squared and our dv is e to the x dx. So differentiate u 2x dx and then integrate dv. Integral of e to the x dx is simply e to the x. Option 2, our u would be e to the x and then dv would be x squared dx. So differentiate u e to the x dx and then integrate dv, it will result to x cubed over 3. And again, examine the second term sa integration by parts, integral of v du. So for option 1, integral of e to the x times 2x dx, di ba? Although they are not similar in nature, algebraic and exponential, but at least the power of x reduces or nag-reduce or nag-decrease. Whereas for option 2, integral of v du, x cubed over 3 e to the x. What happens is, ga-increase ang power, which is not a good choice ba? Or one. Because as much as possible, we're going to decrease the exponent of x. Therefore, we will choose option 1. Okay. At least from x squared, it becomes x now. So integral of u dv is u times v minus integral of v du. Okay. So the next step is you can put 2 before the integral, like this one. Okay, so what happens is this integral will be solved using integration by parts again. Or dili man sila similar, they are not similar in nature. Algebraic and exponential. So, sige. But then, we have an idea na our u and dv will be similar to this and not this one. Because if you use ex as your e raised to x as your u, it will result to this one, an increase of x power sa x. So, let u equal to x dv e to the x dx and derivative of u dx lang, integral of dv e to the x. So the next step will be this one. X squared times e to the x minus 2. The result of this integral of u dv is u times v minus integral of v du. Okay. Now, this is a standard form. So we can easily integrate this one. So, the result will be this. Minus 2 uv minus this one, integral of e to the x dx, and then plus c. And then distribute. Okay. Now, sa integral calculus, if you multiply c, which is a constant, if you multiply a constant by another constant, the result will be a constant. Yeah? Oh, so, since arbitrary, we can just replace this one by merely c. Same lang kay constant multiplied by another constant is still a constant. No? Now, you can choose another variable like d, e, or f, etc. Oh. But we can also use c. And instead of negative, we can just use plus. No? Okay, anyway, constitutively arbitrary lang. Oh, because c can be negative. So, negative 2 times negative, it becomes positive. Ba? So, we can just replace this one by plus c. So, the final answer would be this. So, even if negative siya or nasa coefficient, it will still be, we can still substitute or replace it by plus c. Oh. And this is our final answer. So, first example is algebraic and trigonometric. This example is algebraic and exponential. Our third example is exponential and trigonometric. Same reason, huh? They are not of the same nature. So we can only use integration by parts. So option 1, u is e to the x, and then dv is sine x dx. So derivative of u, e to the x dx, integral of v, integral of sine is negative cosine. Option 2, u is sine x, dv e to the x dx. And our du, derivative sa u is cosine x. And integral of dv, integral of e to the x dx, e to the x. Okay, so again, our focus is on integral of v du. Okay, integral of v du. Negative cosine x e to the x dx. While for option 2, integral of e to the x cosine x dx. They only differ with sign. Eh? So, you can choose any option. 1 or 2. Okay? But for this one, let's use option 1. Okay. You can try option 2. They only differ by sign. Negative e to the x cosine x dx, while this one, e to the x cosine x dx. Anyway, let's use option 1. So option 1, uv. E to the x, negative cosine x, and negative e to the x cosine x. So we do not write negative cosine x times e to the x para dili ta ma-confuse. So we write it as e to the x times cosine x minus integral of v du. Okay? V du. So multiply negative and negative becomes positive. And then rearrange e to the x cosine x dx. Now, the result is this one, integral e to the x cosine x dx. This requires integration by parts again. Okay, we don't have a standard formula for this one. So, we'll use the same one. Selection. U equal to e to the x, and then dv equal to sine x dx. And then du e to the x. This time, our v is positive sine x. Okay. Ang integral sa cosine x, positive sine x. Okay. So this one, uv minus integral of v du. So now, Sa left side, integral e to the x sine x dx. The right side, we also have negative integral e to the x sine x dx. Now, they are the same. Huh? So, what we'll do is transpose this term sa left side. And we'll have this. And so, to get the integral of e to the x sine x dx, we're going to divide the whole equation by 2. So, we have this. Divided 2. Integral of e to the x sin x dx is equal to negative 1/2 e to the x cosine x plus 1/2 e to the x sin x plus 1/2 of c. And again, as explained sa previous problem, sample problem, a constant multiplied by another constant will result to a constant. So we can just replace 1/2 c by c. And the final answer is this. 1/2, let's factor out e to the x. So 1/2 e to the x, quantity, sine x minus cosine x plus c. So with these sample problems, you can solve other problems similar to this. So again, if the given functions are not similar in nature, then use integration by parts. And since we are not yet, it's a trial and error process, they can use several options to choose and then examine later what option will give a simple result sa second term sa integration by parts, which is integral of VDU. Ito ang pinaka-critical, integral of VDU. As much as possible, the function there would be simple. So you have to select the best option. So I hope that you have learned something. Thank you for watching.